Welcome to the IoT Leaders Podcast with me, your host, Nick Earl, the CEO of IoT company SI. This is the podcast, as many of you will know, certainly if you've been listening and watching previous episodes, where we attempt to demystify different aspects of IoT, because we know it's a very complicated world. And in this episode, I'm delighted to welcome our guest from Thales, which is Francis de Souza. And Francis is the head of strategy for Thales worldwide. Francis, welcome to the IoT Leaders Podcast.
Thanks, Nick. Thanks for having me. Glad to be here.
And I know, Francis, you've got a global remit and you're based in Paris. Maybe just for any of our viewers, listeners who are not fully familiar with Thales and perhaps the tie-up with Gemalto, maybe you could explain, briefly to begin with Thales, and then your role, what your role entails before we get into the subject of this podcast, which is all going to be around what's happening in eSIMs and how it works and how we believe it's going to change the industry.
Absolutely. So Thales is a company that is present in different sectors, but all linked with the need to actually have to build, let's say, resilient systems. So the sectors are aerospace, defense, and digital security and cybersecurity. And within this, what Thales does is establishes the world of trust. I'd like to focus on the digital security and cybersecurity part of Thales because you'd inquired about Gemalto. So Gemalto was acquired by Thales, and Gemalto is really the pillar around which the digital and cybersecurity business is being built off. And it works in different sectors. So there's the whole building trust and cybersecurity for mobile operators, for banks and financial systems, for enterprises, for government and public sector, and for IoT. And specifically within the IoT part, I head up the strategy and products for the IoT unit, where what Thales does is brings, first of all, the most resilient cellular connectivity solutions to connect IoT devices. In addition to that, what Thales brings, in addition to the cellular modules that are used to connect devices, the eSIMs and the really advanced technology around eSIM that make for extremely resilient connectivity services, as well as extremely, from a TCO perspective, helping keep total cost of ownership for IoT device makers, service providers under control thanks to eSIM technology. All of this underlined with cybersecurity, because this is essential for all of our businesses today, and particularly for IoT, where if you don't have security by design right at the start on your IoT device or IoT system, you are potentially exposed to a lot of, let's say, bad actors in the chain. And Thales brings these cybersecurity solutions on top of the cellular module and connectivity and the eSIM services for the IoT.
Okay, great. Thank you for that. Now, there was a lot in there, but there was one bit in the middle that was specifically going to double click on. And you mentioned the world of eSIM. So let me just sort of lay out the big picture, at least from my perspective as I see it, and then you can jump in as to what Thales are doing in this area. So broadly, for the last 20, 30 years, we talked about it on previous podcasts, for the last 20, 30 years, arguably since cell phones first came out, there hasn't been so much an eSIM. There has been a proprietary SIM. So there are over 800 mobile network operators in the world. They all have their own IMSI, International Mobile Subscriber Identity. And the way they go to market is their IMSI is loaded into their SIM. So when you contract, particularly from a cellular consumer voice perspective, which is where it was for the first 30 years, you contract with the mobile operator, you got their SIM, and then that SIM always connected to the operator, and then the operator created global reach with roaming. And so you have a lot of roaming agreements between operators, a many-to-many type situation. And that really has been the case pretty much right from the beginning of cellular. But that is now changing. And the whole eSIM, which refers to not embedded as such, but the ability and to actually have a operator agnostic SIM where you can, and I use it analogy of sort of like the way the Kindle works, or some of these ones where you actually, the device will pull down the right IMSI based on its requirements at that time, or a intermediary like an MVNO will load the IMSI based on the requirements at that time. So in other words, it seems to me like it's a pretty fundamental point in the maturity of the mobile network operator, where we're going from a world dominated by proprietary SIMs to this emerging world with these SIMs, which is essentially a generic SIM that can be loaded with IMSIs over the air. Have I broadly laid the table right on that landscape?
You have, though I must point out about the word proprietary, because a lot of the telco industry would come back with a hammer on the word proprietary for the SIM itself, because the SIM itself is completely standardized.
The SIM is standardized, yeah, but what they put in
but what it builds on the stack, yes, I mean, you kind of, it's kind of a SIM issued by an operator.
Yeah.
The eSIM, like you correctly pointed out, is the ability to have at any stage where the hardware is standardized, but the subscription of an operator could be changed during the life cycle. Now, specifically, point of view of an IoT device maker, of IoT service provider, why is this capability useful? And probably even more than consumer devices. The first thing, as an IoT device maker, as an IoT service provider, you're probably building devices to ship around the world. A smart meter manufacturer builds a line of devices, a variant, to go around the world. You might use different operators in different countries. You might not know about it till you're shipping the device or at the point of installation. How do you manage that? If you've got to have a different SIM per operator, per country, it explodes the number of SKUs and variants, stock keeping units, increases your cost of ownership. So this is one point. How do you manage device variety when you're shipping all across the world? Second point, especially for devices that are using cellular networks but tend to be fixed, let's say smart meters or alarm panels, they're fixed locations in the home. In this case, literally the network has to come to the device. The device cannot go to the network. Like in a car, you don't have network, you drive a few meters, you might actually get a network. In this case, the device is fixed. So how does the technician acquire the operator that's present at that point of time where the meter is installed? If you've got eSIM capability, it's literally like you catch out and you pull the network down to the meter. So this is the second point. Smart installation of the operator based on the conditions at the point of installation. The third point is fallback. During the life of any device, network conditions change. So say an operator's base station goes down and suddenly a device is out of coverage. How do you manage situations like this? How do you have backup operators to be able to give you the resilience that you as a service provider are providing your customers? That's the third one. And the fourth one is in-life change. So for example, you have contractual, and this is typical of IoT devices, they might tend to have a long lifetime, 10, 15 years. Smart meters are a very long time. But your telco contracts might be 5, 6 years. And at the end of it, you might have another contract. Either it's because your original telco has done a sunset of the network, or you wish to change, or the M&A, things like that, merger and acquisition between telcos. So how do you update the subscriptions on these devices at the end of a contractual period? And this capability of being able to remotely, digitally be able to change the operator on your device really helps bring cost saving and bring the capability at the time of variant and device management of variants, management of getting the right network at the point of installation of device, ability to have resilience and fallback in case of loss of primary connectivity, and ability to be able to contractually change operators over the air without sending someone, without doing a truck roll, should you wish to do it. And this is the eSIM capability that's now on the market, that's standardized, that's rolled out, that's implemented, that's really starting to make a difference in IoT.
So So you've made as a company, have made a pretty significant announcement in this field.
Absolutely.
Recently. And in fact, one of the first movers in that respect. So maybe you can just recap the announcement you've made as to how those benefits are clearly needed, especially with large multi-region or even global deployments, the fallback to the bootstraps that you're referring to, the ability to switch. And it's interesting that you said the ability to pull rather than push. So all of these things are really important characteristics of the solution. Maybe can you just recap the announcement you've made and sort of talk through it at a high level about how the new solution works?
Absolutely. And I think I'll probably start off with the journey. Okay, so I'm going to take you on a bit of imagination. So mind space, project yourself. So literally, you've got your IoT device. It's got no subscription in it. It's got a SIM hardware, let's call it, but it's literally an empty shell.
Yeah.
At the time of manufacturing the device, you don't know where it's going to go. You don't know which network, where is that particular device going to go. You don't know. All you have, but you do know that out of the, let's say, 100,000 devices you're going to ship, you're probably going to have 40,000 land in Australia, 30,000 land in Japan, 10,000 in the US, take for example. You also have various telco contracts in different parts of the world. All you do is, even before you ship your devices, you go to a portal and you set your provisioning rules. It could be as simple as, if a device shows up in this country, use this telco. If a device, for example, shows up in a country where I have 2 telco contracts, let's say smart metering, typical because you need 2 telco contracts for the coverage. But in these conditions, use telco A, in these conditions, use telco B. And you just set up these provisioning rules. So you just set them up on a platform and you ship your devices. When your devices power on the first time, using the bootstrap, they actually hit your server. They say, where should I get my subscription from? And the server redirects it to that operator based on the provisioning rule, where the device presents an activation code, again, part of the standards, and downloads the subscription. And all this process, starting from an empty shell, you've done your provisioning rules, waking up, hitting the server, saying, where do I get my subscription from, and downloading it from the corresponding MNO, happens in a time that's way shorter than my explanation out there. And this is something we've actually brought to the market. It relies on standardized infrastructure that telcos around the world have put in place to deal with consumer devices like the iPhone and some of the other eSIM-based devices. And we've literally made the cellular module and the eSIM act like these devices. So using existing infrastructure in place around the world to be able to implement this capability for IoT. And that's quite a breakthrough because it addresses most of the pain points that IoT device makers and IoT service providers have when rolling out and making their projects a success.
And just to go a little bit deeper, I mentioned the Kindle as an example of it, but that existing technology, I think I'm right in saying, is what's called the SMDP Plus technology.
Correct.
And that's where it is a pull rather than a push. So one of the differences today in IoT, a lot of the technology involves in you sense a condition and you push an IMSI OTA, but this would be a pull. So the device says, I now need, based on the rules, I need this.
Absolutely.
And it goes and it pulls from the IMSI. So that's the
that's a fundamental difference. And the ability of doing it as a pull rather than the push is that you do things based on real, actual network conditions, real life conditions. It's not based on theoretical stuff where a server is pushing based on assumptions. It's actual real-time conditions where the device sends it back to the server and says, okay, tell me, where should I get my subscription from?
And I think that one of the things that you will provide, and we'll get into who this is for in a minute, but let's say for an MVNO or a CSP, someone who is using this to offer a global capability, you'll provide them with network information, which could be which, as you said, for fixed devices, which networks are available in that exact location, perhaps latency or whatever. So you'll provide network, mobile network information, which they will then write their rules around, which will determine when the pull happens of the UMZ. Yeah,
absolutely. So all of these, let's say, parameters would be passed on either automated or via APIs, and then they could be used by a different provisioning rule engine to decide about making the subscription download.
What about the pricing? What about data pricing? So I understand how the technology will work, and the MNOs. I mean, you have tremendous reach into the world's MNOs. Many of them are customers of yours, especially through the Gemalto side of this. I guess it uses the Gemalto SMSR technology.
SMDP Plus.
Yeah, SMDP Plus, excuse me, technology. But what about the billing and the data pricing? Who determines the pricing for the data? Is that based on a contract between the CSP or MVNO and those operators?
So absolutely. So where Thales comes in is Thales is literally providing the plumbing between the different parts of the ecosystem. Yeah. Thales doesn't get into the contractual relationships between the OEMs and the MNOs or the MVNOs, or between the IoT service provider, let's say, the one that's buying the devices, and the MNOs and MVNOs. So Thales is the enabler, and the IoT device maker or the IoT service provider has the commercial relationships and agreements with people like yourselves, like SI with the other telcos, and uses those commercial relationships to set up the provisioning rules. So Thales doesn't get into that part. Where Thales does is providing the infrastructure to the MNOs and the MVNOs, the SMDP Plus, to be able to bring this capability. And most of the MNOs and MVNOs around the world are equipped with the capability. And Thales provides the cellular module with the eSIMs that go into the IoT devices, as well as the backend platform that does the plumbing between the device, between the SMDP Plus, and has all the subscriptions downloading into devices. And makes it available, Thales makes it available as a very simple commercial model. So you have the hardware on the device, the eSIM, that goes along with the cellular module. So you have one price there. And then you have a transaction fee for every subscription that you download into the device.
Right. Okay. And who's the primary customer? It seems like there could be multiple different types of customers for this solution. So sort of by category, can you sort of...
Absolutely. The customer for which this is the, let's say, the easiest, let's say from an implementation point of view, it's easiest is an IoT device maker also bringing its own connectivity. Let's say, because you have IoT devices makers just make the hardware and then sell it on to someone else who puts together the solution. An IoT device maker that's also bringing in the connectivity. So the package is the device plus the connectivity is ideal for this. And it could actually even be, so you have many customers, for example, e-bike manufacturers. When e-bike manufacturers, they build a device, they also provide the connectivity because that's part of the service. That's a sweet spot for this. You might even have, and you might be surprised to know, in some of, for example, in the smart metering world, the commercial contracts are changing. They move from a hardware model to sell smart meter to the utility, and then the utility buys the connectivity, to a model where the smart meter manufacturer sells metering as a service. In which case, the smart manufacturer sells an SLA, and then does all the negotiations and chooses the best connectivity. That's another typical one. Then there's a model that's a bit hybrid. And let's take the smart metering example, where the smart meter manufacturer will ship the smart meters, but the utility would buy the connectivity. But The problem is not going away if it's utility buying the connectivity or the smart meter manufacturer buying the connectivity. You still have the same problems that the smart meter needs to get the best network, etc. In which case, the hardware, so to speak, is bought by the smart meter manufacturer, and the service to download a subscription is bought by the utility. So those are typically the two kind of models that that exist. And of course, for the infrastructure itself, the SMDP Plus that's on the telco side, that's something that Thales sells to the MNOs or the MVNOs directly.
Yeah. Okay. I got it. I think one of the other areas you touched on in your initial overview was security. Would you say that, and we all know how big a concern security is, and in fact, it continues to be and is actually getting more and more important because of the threat, the expanding edge we talked about on previous podcasts here. But does this solution make things easier to implement a security policy for any of the customers that you've been referring to?
Absolutely. So I'll come back to that in a second, because one of the things about security is there needs to be a concept of security by design. If you don't build in security from the start, you can't retrofit it. And this is easier said than done, because every device is unique, every environment is unique. So the principles of security are quite simple. Putting that into practice is harder. So within the GSMA, there's a new initiative that's launched called IoT Safe, where the SIM is used as a kind of a root of trust and as a base to start to secure the device.
Yeah.
And that SIM could actually be the same eSIM that we've just spoken about earlier to download the subscription of the MNO, the telco that you selected. That SIM could also be used as a root of trust and as the trust anchor in the device for the security of the device itself. So moving forward, what's going to happen is there's going to be a massive deployment of eSIMs and eSIM technology. In parallel, there's a parallel track within the GSMA to standardize security via this IoT Safe initiative. And that capability could reside within the same eSIM we spoke about. So your SIM now becomes your way of acquiring and managing extremely resilient connectivity, and your way of acquiring and managing extremely resilient IoT device security.
And one of the reasons I asked you that is just to actually touch on something that we as SI offer, because I think security is, as we both know, a large complex area, and there are many components. And one of them is the issue of policy, anomaly detection behavior, and deployment of policy to the edge. And so in other words, when do you, how do you spot an infringement? When do you change the security certificate inside the SIM? So one of the things that we have done is a relationship with the agentless security company called Armis that was the subject of a previous podcast. Now, I think this fits in with what you've just said, because my own view as you know, back to my opening comments, my own view of what's going to happen as a result of this change of the, what I call the, I won't use the P word that you tell me not to use, but let's say to a generic SIM, is that you're going to see more adoption. And clearly that's one of the commercial reasons you've done it. It's one of the reasons we're in business. You see more adoption because, as you rightly said at the beginning, people have held back, particularly, you know, we mentioned the 50 billion things that were going to be connected by 2020. We got to 11 billion. It's a classic Pareto. It's the 80% of things that are owned by 20% of the companies that didn't really go to full deployment. And they're the big multi-region global deals, because people want global, the big brands want global solutions. And if they were going to have to change the SIMs all the time and change their backends and their APIs and the support infrastructures, it's too complicated. The ROI wasn't there. But the moment you introduce this, so then I can have a global eSIM And then based on where the device lights up, I can actually have the pull technology to pull the right IMSI at the time. So you have to assume that one of the effects of this will be an increase in adoption. Now, looking at it from and that's the glass half full perspective. Looking at the glass half empty perspective, you say, well, then if IoT security with cellular devices is a problem, then as the number of cellular devices increase, then the security threat perimeter, if you like, increases. So back to what we've done with Armis, Armis, and in case people haven't heard the Armis episode, but they do agentless security. So their philosophy, a California-based company, leader in by far in the agentless security for IoT devices, what they say is, look, that you can never keep pace with the ball that's bouncing down the stairs. You can never actually put a security piece of an agent security like Symantec do on every device, because the number of devices is growing exponentially. So you have to almost like use radar, my words, not theirs, sense what's out there, and then you have a CMDB, configuration management database. Is it behaving properly? Oh, that one's not behaving properly. Take a look at it. My policy is, if it's not behaving properly, quarantine it, inspect, find out what's wrong, and then if need be, change its security certificate. So that would fit into the safe eSIM thing that you're talking about. The challenge for both of us is that the IoT devices that are behind MNO firewalls aren't visible to enterprises because they're one step removed because they're behind the MNO. So as your technology enables more MNOs to basically be switched in and out of devices, because that's essentially what it does, then those devices arguably become even more invisible. So what we've done, I think, is a really important piece of the jigsaw here, because by running here at SI, we run all of our platform, connectivity management platform, over a private network. So think of it as like our own MPLS network. By connecting our MPLS network to Armis's cloud solution, which is connected to the enterprise's MPLS network, essentially you have a single MPLS connectivity to every device, independent of which MNO it's using at any one time. So suddenly you've solved a very important problem. You've extended the perimeter of if you're an enterprise, you've extended the perimeter of your enterprise network to IoT devices that themselves can be on potentially hundreds of MNOs, at which point you can then set policy centrally and have it deployed to the true edge, which is the IoT edge. Mm-hmm. Mm-hmm. And that I think I believe that's going to be really important as companies like your own enable much greater adoption across many more MNOs. That's the glass half full. The glass half empty is people would say, oh, what's that going to do with my security? It's going to make problems worse. Therefore, you have to have governance, policy, compliance, quality of service. It's almost as Armis described it to me, or somebody described it to me, is it's almost like every IoT device, as if it's connected by an Ethernet cable into a Cisco router. But the idea of extending visibility, policy, control to the edge of the network, and I think that's going to be really important, because you literally cannot put agent software on all these devices because they're all made by different manufacturers. A lot of them are sealed. They have pretty poor security. And I think it probably also solves a concern for the device manufacturers, doesn't it? Because they are also worried that any security problem often reflects on the device manufacturer.
Yeah, absolutely. So in fact, what you described, I mean, those are they're complementary efforts, because with things like IoT Safe and Trust Anchor and security by design, it's hygiene factor. It needs to be done. But security by design doesn't mean fire and forget, because security is always a moving target, and hackers are always moving really fast. And what you described of having the ability to constantly scan the behavior of devices, and based on the analytics to be able to detect any device that's, or devices that are behaving abnormally, flag it, set policies, is an essential component. Because again, remember, these are long life devices. So you might have the security by design, and you will have your security policies that are set at the time the device is introduced into the market, which may not be good enough 5-6 years down the line, which is where the ability, besides the good practice of having the ability to update and patch devices in a secure way, the ability to detect this behavior using something like the system you described from Armis is essential. Besides the fact that for many enterprises, if there's not been IoT devices that have been designed with security by design principles, you at least cover for that possibility by having such a kind of solution. So these solutions, one at the during, let's say, during the time of device design and implementation, and the other one constantly during the life cycle of a device, are essential and complementary to each other. So I think that makes for a very good complement.
Okay. Okay. So we've I think got a good understanding, an overview of it. You've announced it recently. Where are you in terms of the project? Are you in the early adopters phase? I guess you've got the MNOs, as you point out, the mobile network operators already have, most of them, I guess, already have SMDP Plus. So it's not like they have to. They already have, because of the consumer devices use the pull technology.
Yeah.
So you're in the process of just rolling out the program now and signing people up to the program?
Absolutely, absolutely. So we've got our first devices shipping, and so we went, classic. We tested the concept, minimum viable proposition, and productize, and rolling out in mass. In fact, for some pretty big rollouts on, I can mention one example because that's public. Besides, there's lots of others which are a bit under the hood right now. But there's a very big smart metering rollout that's happening using this technology up in Scandinavia, and really segments like smart metering really need this technology as well, because of, for example, in Scandinavia, you might not have the best coverage all over in the country, like in every country, by the way. So you need to have this, whereas a smart meter is fixed at the location on the wall, at the meter where the non-smart meter, at the location where the non-smart meter was fixed. So rather than have technician go out trying to figure out the best network, the antennas and everything, this intelligence is built in, and the eSIM downloads the subscription that's needed at that point of time. So this is commercialized, rolling out on CAT-M networks, on LTE Cat1 networks, on LTE Cat NB IoT networks as well. It's been tested, works brilliantly on Cat NB networks as well. So this is very, very much production grade, rolling out in implementation, in deployments, and under testing beyond the ones that are already in deployment, under testing with a host of customers. And at the same time, there are many MNOs and MVNOs also onboarding into the platform, so that as they sign up contracts on their side with device makers could also use this capability.
Okay. All right. Great. So, Francis, if any of our listeners wanted to get in touch with you to find out more, how would they do that?
Well, you got my francis.d'souza@thalesgroup.com email ID. But besides that, at any point of time, you could just go to the Thales website, thalesgroup.com/IoT. Just fill up a form request and get in touch with us. Or, I mean, we've been doing, especially on this topic of what we call the IoT eSIM. You put in a search for IoT eSIM on LinkedIn, you'll have plenty of stuff that pops up. You'll have me in a lot of different videos. Connect with me on LinkedIn and we can take it from there.
Yeah, and I've been on there and I've seen there's quite a few explanation videos, and
absolutely.
Download white paper and do your research.
Absolutely.
Great. All right. Well, I think that's probably a good overview for people, and hopefully people do visit the website and find out more. So why don't we leave it there? Thank you very much for appearing on this episode of IoT Leaders Podcast. This is exactly what we wanted to do when we designed this series, is really shine a light on how to navigate through a lot of the complexities IoT, and certainly this area of being able to get large global deployments, to be able to simplify the deployment and to actually have choice, agnostic choice across different operators is something that many of our previous speakers have spoken about. So I'm sure it will be successful. So I'd like to finish by, again, thanking Francis D'Souza from Thales, and thanking you for listening. We'll be doing more IoT Leaders Podcast. If you do need to get in touch with me, I'm Nick Earl, CEO of SI. You can find me on LinkedIn, but also we have our email address as well, which is iotleaders@sieseye.com. So thanks for listening, and I look forward to talking to you all at the next episode. Thanks again for tuning in.